Assalamualaikum warahmatullahi wabarakatuh. Good morning. Thank you for coming to this presentation, and thank you to the committee of the third IC-FSSAT 2020 for giving us the opportunity. Let me introduce myself. My name is Rizki Chairiyah as a presenter, and my research teams are Khadijah Ramija and Siti Fatimah Batubara. I am a researcher from Assessment Institute for Agricultural Technology, North Sumatra. The title of the research is Liming of Acid Soil and the Interaction with Soil pH and Corn Productivity. List of presentation are Introduction, Methods, Result, and Conclusion. This research background is acid soil problem in Indonesia. Acid dryland in Indonesia is 102.8 million hectares or 69.4% of the total dryland. Acid dryland is characterized by pH less than 5 and base saturation less than 50%. Soils that have an acidic pH in dryland are the orders of antisols, insectisols, ultisols, oxysols, spodosols, with wet climates and high rainfall. Low soil pH is associated with high aluminum levels, high phosphate fixation, low alkali exchangeable, low CaC, iron and manganese contents are close to poisoning limits, and poor in biotic elements. Liming is the dominant technology used for increasing soil pH. Lime application will bring aluminum and iron elements that the levels are excessive toxin to plants, also free phosphate and potassium nutrients available to plants. The effectiveness of the lime can be seen from the effect of liming to the physical or chemical properties of the soil and its effect on plants. The objective of the research are to test the effectiveness of dolomite in improving soil pH, corn productivity, and optimum dose of dolomite. Field testing was done in farmers' land at Pasar 6 Kuala Mencirim Village, Sebingi District, Langkat Regency, North Sumatra. Soil analysis at Ayat, North Sumatra Laboratory. Dolomite quality at IOPRI Laboratory. The research has been done from April to August 2020. The materials used in the research are hybrid corn seeds, dolomite, urea, SP36, and KCl fertilizer. The tools used include cultivation tools like wooden dibber, rakes, sprayers, tape measures, scales, computers, and the IBM SPSS version 20 statistical software to process the data. The study used a non-factorial randomized complete block design with 7 treatments are D0, D1, D2, D3, D4, D5, and standard dolomite. The parameters observed in soil analysis prior to implementation was soil chemical properties, and the parameters observed after treatment were the increase of soil pH at week 2, 4, 6, 9, and 12 weeks after planting, plant height, and corn production. The yield parameter observed was corn production. Assessment of the effectiveness of dolomite was carried out by comparing relative agronomic effectiveness value of standard treatment with dolomite treatment. To determine the effect of treatment given, analysis of variance was used and followed by further tests of significant differences between treatments using the Duncan multivariate test at a 5% confidence interval for plant height and production data. The effectiveness of the fertilizer tested was calculated using the RAE value. The dolomite quality results showed that the dolomite quality has met the minimum technical requirements for dolomite based on SNI. The soil characteristics prior to testing results show that a low soil pH of 4.76 is acid, so application of dolomite is appropriate. Soil organic carbon content is very high, Total soil nitrogen is moderate, available soil phosphate and potassium are low, manganese content is low, micronutrient content is sufficient, and the soil texture is classified as loamy sand class. The soil pH measurement from 2nd to 12 weeks after planting results show that the dolomite has an effect on increasing soil pH at 2, 4, and 6 weeks, whereas at 8 and 12 weeks the increase in soil pH is no longer, it happens again. The highest increase is soil pH at 2nd week of the treatment D4 and D5. There was an increase in soil pH by 0.98 from the control treatment without dolomite application. The annual analysis and the further DMRT test on paint head measurement from 2nd to 12 weeks after planting showed that the effect of dolomite application on corn plant head compared to the control treatment and standard dolomite was significantly different from 4th, 6th, and 8th weeks. The result of ANOVA analysis and 4D-MRT tests on corn productivity showed that the application of dolomite significantly different to the production of corn compared to control and standard dolomite treatment. The highest corn production was found in the D4 treatment and the lowest was in the control treatment. The result of RAE showed that a fertilizer is declared agronomically effective if it has a relative agronomic effectiveness value more than 95%. It means that fertilizer can increase the yield greater than the treatment without dolomite and compare fertilizer or standard dolomite. The highest RAE value was in the D2 treatment. The conclusions of the research are: application of the dolomite can increase soil pH in acid soils. The provision of dolomite with the resulted in higher plant height and higher corn production than the control and standard dolomite treatment. All dolomite treatments have RAE more than 95%, and optimum dose of dolomite is 2 tons per hectare on acid soils. That's our presentation from the research about liming of acid soil and the interaction with soil pH and corn productivity. Thank you for listening. May all those we have shared be beneficial for all of us. Assalamualaikum warahmatullahi wabarakatuh.